Welcome back to our grade 10 chemistry. We're really on the home run now where we're starting to tie everything back together and put it all into chemical equations. Okay, that's what we're looking at today. So by the end of this, we're going to write word equations to represent chemical reactions, identify balanced and unbalanced chemical equations. That's kind of the stuff I've started sort of showing you here and there. And we're going to actually balance the ones. All right, and there's your Lady Gaga formula from the old chemistry cat. So we did the experiment last time, which is about the solubility of ionic compounds. Think about how we mix those together when we had copper sulfate and ammonium carbonate. You mix them together, and what do we end up with? There's a precipitate because we have copper carbonate and the ammonium sulfate stayed dissolved. So if we think about this, what are the reactants? The reactants are the things that we started with. That's those guys. The products, that's what we ended up with, the ones written in that line. So see if you can write that as a word equation. What we have is, I haven't got a lot of space here on my screen, we have copper sulfate plus ammonium carbonate reacts to give, normally I'd write this on one line and that arrow would be sort of over on the end there, but I've run out of space. Copper carbonate plus ammonium sulfate. Right, now the thing it tells us is that we did have a precipitate, which was the copper carbonate, so that one is a solid, whereas the rest of them are aqueous. This one up here is aqueous, and that is aqueous. So we can write that sort of a little subscript AQ for all of them, but we specify that the copper carbonate is a solid because it came out of solution. That is our precipitate that we saw down there. So when we talk about balanced equations, we've come across the law of conservation of matter before. It just basically tells us matter is not created or destroyed. It's got to go somewhere. So all the matter making up the reactants in a reaction must appear in the products of the chemical reaction. You can't have more or less matter on either side because that's just creating matter out of nothing, and that's impossible. So what this means for us is the number of each type of atom must be the same on both sides of the arrow, the products versus the reactants. And here's a nice example. So we have two cracker squares, which we've made up a little formula for that one, plus one marshmallow, plus three chocolate squares makes a s'more, which is yummy, yummy, yummy. But if you think about how we've done it, we've got two CQ, which is our cracker square. There's CQ with a little 2. We have one marshmallow, which is MM. We have one MM over here. We have three chocolate squares, which is a CH. And we have CH3 over there. See how it sort of balances either side. There's the same number on the product side as there is on the reactant side, other way around. Same number on the reactants on the left as there are products on the right. And that's the name of the game for balancing equations. That's what you will do when you do this yourself. Here's a little interactive thing for us to have a look at. Have a go at that one. Click on the directions, click OK, start your game, and have a crack at that one. I'll put the link in the thing below anyway. But let's have a look at how we do some of this. So here's equation 1. We have Fe, which is iron. There's one iron atom there, and we have one iron atom over the other side. We have one sulfur atom, and we have one sulfur atom over there. So we have the same numbers of ions on the left and right, and the same number of sulfurs on the left and right. So that is a balanced equation. We don't need to do anything to it. But let's look at the second one. In the second one, we've got two hydrogen atoms and two chlorine atoms. But on the right-hand side in the products, we have 1 and 1. So that doesn't balance. So I can't change these little numbers like that over here in the products. But what I can change is how many of those compounds there are. I can do that by adding a big 2 in front of it. If I have 2 of them, now I have 2 lots of hydrogen and 2 lots of chlorine, and that's going to balance the other side. That's how we balance these equations. Let's look at the next one. On the left-hand side, we have 3, my mistake. Let's write that out. On the left-hand side, we have, I can't write, 1 magnesium, and we have 2 oxygens. On the right-hand side, we have 1 by magnesium, so that's right. But we only have 1 oxygen, so that doesn't really work, does it? So what we're going to have to do is change the numbers to make it balance. So if I put a 2 in here, what I've done is I now have 2 oxygens on this side and 2 magnesiums on this side. So I've balanced my oxygens, that's the same on either side, but I haven't balanced my magnesiums now. I need an extra one over here to make it balance. So if I put a 2 in there, I have 2 magnesiums on this side, 2 on this side, and I'm now balanced. So by putting those numbers in there, by putting that and that in there, this is now the balanced equation. Okay? Let's try another one. We have number 4 there. We have on the reactant side 2 oxygens and 2 by hydrogen. On the right hand side, we have 1 oxygen and 2 hydrogens. So I have to balance it. And the only thing I can do is put those big numbers in. I can't change those little subscript numbers that are already listed in there. I can't just write a 2 in there because that's not the same formula. That's a different formula. That's not H2O, which is water. That becomes H2O2, which is like peroxide. So what do I have to do? I'll put a 2 in there. And that will give me double the number of oxygens. So that's cool. But it now gives me 4 hydrogens. So if I put a 2 in here now, 2 times 2 is 4 hydrogens. Now we have a balanced equation. Alright, let's look at the next one. Now, notice this here. As you go on, you start looking at other reactions. Starting with oxygen is not always the easiest. And that'll sort of come in down here in number 6. Let's have a look at number 5. What do we have? 1 Hg, which is mercury, and 1 oxygen. 1 mercury, 2 oxygens. So I need to add a 2 here to balance my oxygens. But now my mercuries are out of whack. So I put a 2 in there, and that's now balanced. Question 6 is a little bit more complicated. So what do we got in the reactants? We've got 1 by calcium, 2 by hydrogen, and 1 by oxygen. In the products, we have 1 by calcium. Now this is a bit weird. We have the brackets here, so that means 2 lots of everything inside the brackets. So as far as oxygen is concerned, I have 2 by oxygens. This hydrogen is repeated twice, so I have 2 hydrogens there, and I have 2 hydrogens over there. So I have 4 by hydrogen. That was 2 there and 2 there. So, how are we going to balance this guy? Now, my calciums are fine, my oxygens are not, and my hydrogens are not. Okay, so I'm going to have to equal this somehow. Now, the only way to affect the oxygens on the product side is that one there. If I have 1 oxygen on this side, 2 here, I need to change my oxygens on the products, the reactants, sorry. I'll put a 2 in there because what that's going to do is now give me 2 oxygens on that side, which balances my 2 there. That's good. But what have I changed now? I've changed my hydrogens. 2 times 2 is 4 hydrogens. That's 4 hydrogens, so that's now balanced. And my calciums are all balanced as well. Okay, so it's a little bit of a process of elimination of going through things. So that one worked out being easy in that we really only had to put one number in there. Here's some more to have a look at. I encourage you to pause the video, have a go at them before you move on. Notice how I got those 3 oxygens over in the products there on the right hand side. 2 in the carbon dioxide, 1 in the water. Alright, so let's have a look. My carbons are balanced both sides, my hydrogens are not, and my oxygens are not. And this is going to be a little bit complicated. So, you've got to kind of start playing around with it to see what will balance. So if I've got 4 hydrogens on the left hand side, the only place I can change my hydrogens in the products is that one there. So if I put a 2 in there, what do I now have? I now have 2 times 2, which is 4 hydrogens. 4 hydrogens, that's good. But now I have 2 oxygens there, 2 oxygens there. I have 4 oxygens. 2 in the carbon dioxide and 2 in the water. So I have to change the other side. So if I put 2 in there, what do I now have? 2 times 2 is 4 oxygens, all balanced. See how we did that one? By adding the 2 in front of the oxygen and the 2 in front of the water. Now I've got 2 oxygens there and 4 oxygens there, so that would be 6 oxygens. On the other side, and as far as oxygens go, 4 there, 2 there is 6. And if you have a look at that, that's already balanced. 2 sodiums, 2 sodiums, 2 hydrogens, 2 hydrogens, 1 sulfur, 1 sulfur, 6 oxygens, 6 oxygens. Don't need to touch it. All right, last one. So you can see that none of these are balanced on either side. So let's start with our nitrogens. I have 2 over there, but 1 over there. So if I put a 2 in front of him, that makes that 2. That's all good. But now I've changed my hydrogens. 2 times 3 is 6 hydrogens. So if I put a 3 in front of him, 3 times 2 is 6 hydrogens. All good. Okay, so there's the process where we keep going through, where we keep adding them in as we go. Okay, now these ones get a little bit harder, particularly when we look at question 11, because there's a little bit going on here. Question 10, have a go at that one yourself. Pause the video, check them out, and then I'll go through the answers. Okay. 1 by aluminium, 2 by oxygen. 2 aluminium and 3 by oxygen. Now, it would be tempting and easy just to say 2 aluminiums there, 2 aluminiums there, they balance, but the oxygens don't balance. 2 on one side, 3 on the other. Now the easiest way to do this is, there's a 2 there, put a 2 there, which means we now have 6 oxygens, and there's a 3 there, so we put a 3 there, which means we have the 6 oxygens there. What it's also changed is 2 times 2 is 4 aluminiums. So I need 4 there to create the 4 there. Okay, so let's just tidy that up. You need 4, 3, and 2. Okay, now this next one's a little bit of a challenge. Let's tidy up our screen a bit. So, start with K, our potassium. 2 there, only 1 there, so we think, oh, we can chuck a 2 in there. That's balanced. Now we have 2 of the manganese, put a 2 in there. So our potassiums, our Ks are balanced, our manganese, our Mns are balanced, but the oxygens are going to be a bit of a drama. On the left-hand side, 2 times 4 is 8 oxygens. On the right-hand side, we have 1 there, we have 2 there, and we have 2 there. So that's 5 oxygens. And it would be easy to think, oh, well, hang on. If I just put a 2 in front of that one, that would be 4 oxygens. So it's now 4 plus 2 plus 1. That's 7 oxygens, but I need 8 over there. So it's not really going to work. So what we have to do is start playing around with how many of the other elements we have to actually make this balance. So tidy it up again. Because none of all that's going to work. Alright, so let's go a bit of a different tact. Let's say we put a 2 in there, because 1 in there didn't work before. So if we put a 2 in there, what that means is we're going to need a 4 over here, because 2 times 2 is 4 potassiums. We now have 4 potassiums. But now we also have 4 of the manganese. So we need a 4 in there. So I've got my potassiums balanced, I've got my manganese balanced. Let's look at oxygen. 4 times 4 is 16 oxygens. I have 2 of them there because it's 2 lots of that. I have 4 of them there, and I have 2 there. So in my products, 2 plus 4 plus 2, 7 oxygens. All right, let's look at this a slightly different way. If I have 2 oxygens in that lot and 4 in that lot, I have 6 oxygens so far. I need to get to 16, so I need to add 10 more. If that's 2, 5 times 2 is 10, plus the 6 I had, makes the 16 I need. So there's my completed reaction. I put a 4 in there, a 2 in there, a 4 in there, and a 5 in there. There's a few more for you to have a go in your own time. Pause the video, take a screenshot, whatever you need to do, have a go at those ones. Here's another task where we write a word equation and we start putting all these together in a little bit more detail. So if we look at the first one, we have solid carbon. So we're going to have carbon, solid, reacting with water, which is obviously aqueous, to produce carbon monoxide gas. Plus hydrogen. And that's going to be a gas, and that's going to be a gas. All right, there's my word equation. Let's do our formulas. Carbon, as it says, is C, and water we know is H2O. We're going to need carbon monoxide gas, which is that one. Carbon monoxide, 1 oxygen, and hydrogen always goes like that, H2. So my chemical equation, I'm going to have carbon. Oh, before I go on, is it balanced? I have one carbon. Whoop, that color doesn't work. 1 carbon there and 1 carbon there. 2 hydrogens, an oxygen, and an oxygen. So it is balanced. So I have carbon, which was solid, plus water. You don't really need to write anything for this one, but it does say it's water vapor. So that would be water in the gaseous state, giving us carbon monoxide gas plus hydrogen gaseous, like that. Notice how I put those little letters in brackets underneath it. The only other one that I would use is AQ for aqueous, as in it's dissolved in liquid. You can have a go at the rest of them. Have a go at those ones too. Keep going, doing exactly what I did. Notice they start to get a little bit harder down the end here. Keep trying them. Pause the screen at each one and have a go. Same. Have a crack at this one. Even more to have a go at. Do exactly the same thing that you just saw me do. Okay, go to your textbook, the Jacaranda Science Quest 3. Check out those questions there. I highly encourage you to read this summary on page 181. Very worth your while doing. Have a look at the questions on page 182. That is the bare minimum. And that's kind of like barely scraping through. I suggest you do all of those questions in that chapter review section just to make sure you understand all of it. Okay, think about what we've done today, writing some equations. Next time we're going to write more. Thank you for coming.